In case you cannot see that, and you probably won't be able to see that, we see one basic primary objective of the course is to basically inculcate within you a sense of joy of discovery, a sense of curiosity. Hopefully थोड़ा बहुत आपका already sense है उस curiosity का, that's why you are in science and engineering. So in case you cannot see this, this is essentially a little cartoon. A person essentially has touched something, he or she receives an electric shock. And what a normal person does is, of course, a normal person deduces that, I guess I shouldn't do that. But if you are scientifically minded, if you belong to the school of science and engineering, what you should be doing is, well, touch it again. I wonder if the same thing happens again. And so hopefully by the end of this course, you get some sense of the joy of discovery. Okay? If I manage to put that into you, I've succeeded. Even though, you might not be applying Newton's second law correctly, but that's a byproduct for this course. Okay? Okay. So of course I have to give you one compulsory slide on what is physics, okay? Of course I can go back to the time of ancient Greeks, okay, and so on. I won't be doing that. Physics is very simple to tell you about that. What is physics? Physics is basically the study of everything you can possibly think of, essentially. Anything that you can see, that falls under physics. Anything that you don't see also falls under physics. So physics goes all the way from electrons, which you cannot see, all the way to the observable universe, which you can also not see. Okay, so in between, of course, are things that you can see. Okay, like with your bare eyes, you just need to look downwards to see one of the planets, the planet on which you are standing or sitting. Okay. Why is physics still important? Physics is of course important because it has always been important, and it will remain important because it lies at the nexus of every other science. It lies at the nexus of food, water and energy. For example, climate science plays a big role in that, and physics is a central component of climate science. So different regions with the same water availability experience different rainfall. Why is that? That is essentially a physics question. Physics tries to understand essentially where we come from, where are we going. The composition of the universe is a central component of all your existing technologies, all your emerging technologies. Okay, so back in the 1970s, most employees in Intel, for example, had physics degrees because you didn't have exactly specialization yet in electronics and so on. It's later on that those got specialized, and then people started becoming electronics engineers and so on. And that's the case with any emerging technology. Another area, of course, is medicine and biophysics. So that's just one example, okay, in which physics is still very, very relevant. Okay, so for example, one big thrust these days in physics research is to make extremely sensitive sensors. NMR essentially relies on essentially if you can get much higher resolution of what your body is looking like, if you can detect very, very weak magnetic fields, for example. So if you can design sensors that can detect those very weak magnetic fields, then you get a much higher resolution image of what your body looks like from the inside. That's essentially a physics problem. Okay. So physics courses in your freshman year, there are 2 physics courses. Thankfully, you're doing only one of them this semester. The next one, okay, the next horseman of the apocalypse is there in the next semester. You have mechanics and modern physics. इसको मैं बार-बार mistake कर रहा हूँ slide के लिए सही है. Okay. Here's the good news. The good news is that the basic fundamentals of mechanics you already know. I'm not talking about your O-level or metric or FSC or A-levels. I'm talking about you know the basic fundamentals to some extent since you were 3 months old. Since you grabbed your first rattler or you grabbed your first toy and you threw it at your mother or father, okay? You have been studying mechanics, okay? You kind of know already how an object will move. That's part of common experience. You have seen cars moving all around you. You have seen, your friends running. You have experienced running yourself as well, hopefully. Okay, it's a part of common experience. Mechanics is essentially the studying the physics of moving objects and moving objects which you can easily see. This is not weird science. This is everyday science. Okay, if you cannot explain this mathematically, what hope do you have in explaining the behavior of an electron? What hope do you have in building, a very complicated AI model, which you have no idea कि ये क्या predict करेगा when you cannot even do this? Okay. Okay. The bad news, unfortunately, is the following. And I need to be honest with you. Unfortunately, आपको सारा ये मजाक लग रहा होगा, of course, अभी सर ये तो हमें आता है, A level में हमने किया हुआ है, अम्मा अब्बा कहते हैं कि बच्चा पैदा ही जीनियस हुआ था. Okay. Well, unfortunately, that's not the case. Okay. My one unforeseen result of this course is that I bring a lot of people down to earth. That's so, unfortunately. मेरी नीयत नहीं होती. I would like to be proven otherwise, but that's the case. Okay. So unfortunately, the reality is that you will think that this is by far. I'm not saying it's not even fair. It's considered to be by far the toughest course in your first semester. ये मेरी वजह नहीं है. लोअर लोगों ने पढ़ाया था I think I taught it for 2 years, 2 or 3 years consecutively, and then students सर बहुत मुश्किल है बहुत. वो दूसरे इंस्ट्रक्टर ने पढ़ा कहता सर आप पढ़ा लें please. So it's not a matter with me, okay? अगर आप MIT students से भी freshman से उन्होंने पूछा कौन सा सबसे मुश्किल कोर्स है, mechanics है science. And there's a reason behind that. Okay, so you have to go. The very first thing that you have to learn is to unlearn the way that you did physics in your high school. That was all about learning equations, figuring out कि कौन सी quantity इस equation किधर घुसाऊं सच के number बाहर आए और वो मैं कहूँ ये answer है. That is not physics, okay? Physics is about relating different physical quantities, about building mathematical models to explain your observed phenomena, and then to make predictions out of this model, to analyze what this model is telling you, to understand this language of mathematics in which the model is written. That is what physics is all about. Okay? So mind your GPA, by the way. इसमें अगर बुरा ऑफ कोर्स आप कहोगे सर मुझे कंप्यूटर साइंस करनी है, इसके अंदर तो मैं वो मेरे सीनियर ने कहा था कि आप वो ना फाइनल एग्जाम अच्छा कर लो तो B- आ जाएगा, कंप्यूटर साइंस करेंगे, अल्लाह खैर सला फुल स्टैक डेवलपर बन जाएंगे, सेट फॉर लाइफ हो गया. Well, do well in this course and you'll probably be even better set for life, okay? It's not very difficult to do in this course. So that's one side of the story. The other side is it's very easy to do well in this course as well. If you should just be consistent, okay? Right? Okay. So, of course, the first question is you should be asking is कि मैं इस कमरे में कर क्या रहा हूँ या कर क्या रही हूँ, okay? Why am I being forced to do this course? Okay? वो मेरा दोस्त जो फास्ट में है वो तो जल्दी से जो है वो थोड़ी सी फिजिक्स करके जो है वो फुल स्टैक डेवलपर बन जाता है, मुझे क्यों इतनी फिजिक्स हुई अजियत दी जा रही है, okay? There's a reason behind that. There are lots of reasons, okay? And because this course may seem like stupid, okay? Why are we learning about pushing boxes? Why are we learning about me pushing my friend? That might be useful, okay, in some contexts, okay. Why am I learning about, tying a rope to a box and then pulling it? Why am I learning about how wheels move? That's not the point, okay. As you'll see in this course, that's not really the point, okay. But first of all, you need to learn about these things because this is the simplest area in which all these ideas of modern physics are introduced. Energy, information, and so on and so forth. And that's basically the language of modern science. If you don't understand that language, you won't be able to contribute to any emerging technology. Any possible emerging technology will be talking about energy, for example. You need to be able to quantify it. You need to be able to understand it on quantitative terms, not a vague qualitative terms. और अगर सिर्फ वो वेग अंडरस्टैंडिंग करनी है फिर आपको HSS वाला जो आपका बॉस है और आप में क्या फ़र्क होगा, okay? Okay, so just to give you an example, this is from a business school, okay? Business school, highly appropriate, okay? So anyway, so this is essentially a growth chart of the revenue earned by the semiconductor industry in some currency. I forget which currency it is. I think maybe it's USD, okay? But anyway, it shows a year, but on the horizontal axis you have the years. So you can see in 1957 there was basically nothing, and then around 1967 there about the first transistor was invented. That's right about here. And then, it's still this small steady growth, and then it exponentially shoots up. Any emerging technology, that's how it behaves. The first few years are very stagnant, and then suddenly it shoots up. Basically, the same thing has happened with AI. Okay, so the idea is that, for example, there are many different emerging technologies these days. There are all kinds of quantum technologies, there are all kinds of other technologies. If you look at quantum technologies, for example, this is basically estimated position for quantum technology today. So basically, we are at the equivalent of 1970 as far as quantum technology is concerned. If you want to enter any emerging technology, now is the time. जो इंटेल में शुरू में लोग गए थे वो ऑफ कोर्स they didn't do much and they still became multimillionaires. जो टेक्नोलॉजी एस्टेब्लिश हो जाती है उसमें एंट्री ऑफ कोर्स the entry barrier is much higher. The competition is much bigger. So if you want to enter any emerging technology, and to do that, of course, you need to be good at basic science. You need to be good at your fundamentals, क्योंकि आपने ट्रेल ब्लेजर होना है, किसी और ने नहीं. आपने लोगों का काम कॉपी नहीं करना, आपने खुद से एस्टेब्लिश करना है. But now is the time to do it. Okay? मेरी ये कहनी है, even India has recently invested more than $1 billion into quantum technologies. हम सोच रहे हैं. Okay. By the way, if you talk to me कि भाई रीजन में हम सारे इकोनॉमिस्ट वगैरह बड़े लगे रहते हैं कि भाई इस रीजन में साउथ एशिया में पाकिस्तान इतना पीछे क्यों रह गया है, उनकी सिंपल सी वजह सबसे कम हमने सेमीकंडक्टर इंडस्ट्री में सबसे कम हमने इन्वेस्ट किया था. हमने सारे सेमीकंडक्टर रेवोल्यूशन को दूर से टाटा कर दिया. ओके सर, इट्स ऑल अबाउट हाउ मच यू सेल. अच्छा खैर, एनीवे, ओके, बट मोस्ट इंपॉर्टेंटली दिस कोर्स टीचेस यू अबाउट हाउ टू थिंक साइंटिफिकली. It's not really a course about, like I said, about pushing boxes. It's about how do you model that situation. How do you build a mathematical model of a person pushing a box, then write equations that describe that mathematical model, analyzes it, makes predictions, testable predictions. That's what this course is about. Okay? And basically, even if you ask what is science, here's a quote by von Neumann. आप कंप्यूटर साइंस में आपको तो पता होना चाहिए who is von Neumann. Okay? The sciences do not try to explain, they hardly even try to interpret. This is the brutal reality. अगर आप philosophy of science में ना जाओ, basic science is all about constructing a mathematical model. They mainly make models, mathematical models. By a model is meant a mathematical construct which, with the addition of certain verbal interpretations. What does he mean by verbal interpretation? There are some quantities which you never talk about, neither mathematically nor verbally. For example, charge. So when electricity magnetism, when you did electricity magnetism, there's a lot of mention of this quantity called charge. कभी टीचर ने कहा था कि what is charge? उसको तो आप bypass कर देते हो. It's kind of a given. You have some kind of vague, nebulous understanding of what is charge. Similarly, in mechanics, we don't really talk about what is time. We just talk about, oh well, we have a vague understanding of what we mean by time, and then we move on. Okay, we give you some idea of how to measure time, but we don't talk about what is time. Okay, so that's what is meant by certain verbal interpretations. Describes observed phenomena. So you take some things as given, construct some things as derived, construct a mathematical model, make predictions. That's essentially what science is all about. That's what computer science is all about, if you want to be particular. Okay? Right? Okay. You need to be a critical thinker, and that's precisely the problem that we start off from today. You throw something, well, you ask the first question that people always ask is, why does it fall down? Well, even if you throw it upwards, eventually it does fall down. Why does it do that? That's a question that you asked probably when you were 5 years old, or maybe not. Okay. But the more important question, first of all, given that what I've just told you about constructing mathematical models, the more important question is to first take a step back and ask, how does it fall down? As in, describe its motion mathematically. And then we can make progress. Okay? That was the big step that was taken by mankind. Because ancient Greeks were already wondering about why do objects fall down. But a couple of thousand years later, people discovered that it's much more important to first ask, how do objects fall down? And then worry about why does it fall down. Okay? Right? Okay, so just for those के लोग कहते हैं सर सिर्फ कंप्यूटर साइंस में ही है, वेल कंप्यूटर साइंस वाले भी इतने भी स्मार्ट नहीं होते, ओके, वो भी फंसे पड़े होते हैं कि क्या करना है, ओके. So these scientists are saying our field has been struggling with this problem for years, and the computer scientist comes in and says, struggle no more. I'm here to solve it with algorithms. And 6 months later, of course, that person has made absolutely no progress, okay. Wow, this problem is really hard, okay. And so, to be a good computer scientist, you need to know some other fields as well. The prime example, one example being, for example, आप AI में बड़े specialist हो, and you have been hired to make an AI model which essentially you feed it in some medical scans, and the AI model tells you whether you have some disease or not. You can only do that if you know some biology. Otherwise, आपका AI model कुछ का कुछ बता देगा, आपको पता ही नहीं चलना, okay. You need to know something about the basic sciences in order to be a good computer scientist, okay. और ये कोई ज़्यादा advanced चीज़ नहीं है, these are basic freshman level things, okay. Okay, that's what I'm doing, okay. So जब ये कोर्स कर लेते हैं लोग, उसके बाद तो उनको 3 सालों के बाद एहसास होता है, कई दफ़ा इस किस्म के कई मेल्स मुझे आती हैं कि 3 सालों के बाद एहसास होता है कि ओ अच्छा वो जो पढ़ा था वो कुछ काम आ रहा है, ओके. So, but it takes some time, okay. So hopefully for you it won't take that long. So we'll start, of course, this week from explaining the language, applying the language. I won't explain it, okay. I'll assume that you already know the language to some extent. The language in which the laws of mechanics are written down, and in fact the laws of most of science and engineering are written down. I won't say all, but the laws of most of science and engineering are written down is the language of calculus, okay. So that's the branch of mathematics which provides the basic language in which you write down, in which you describe your mathematical models, okay. So you need to be good with this language. If you're not good with this language, वो आपको इस तरह ही लग रहा होगा जैसे मैं फ्रेंच बोल रहा हूँ, okay. So no, you need to be able to speak this language. You need to be able to understand this language, okay. And मुझे पता है आप सबको नोट्स लेने का बहुत शौक होता है. डोंट बॉदर, आपको रीडिंग्स में सब कुछ मिल जाएगा, इक्वेशंस वगैरह ऑलरेडी मिल जाएंगे. बट यू शुड बॉदर विद, ऑन द अदर हैंड, इज इंस्टेड ऑफ मेकिंग डिटेल्ड नोट्स, जस्ट राइट डाउन द की स्टेप्स. मैं आपके रीडिंग्स हमेशा एक हफ्ते बाद अपलोड सिर्फ इसलिए करता हूँ सो दैट आई गिव एवरीबडी फेयर चांस कि वो घर जाके खुद से रिप्रोड्यूस करने की कोशिश करें जो क्लास में किया था. दैट्स द ओनली वे दैट यू एक्चुअली लर्न दिस मटेरियल. यू लर्न फिजिक्स बाय डूइंग, नॉट बाय लिस्निंग टू मी, ओके. अगर आप किसी की स्विमिंग करते हुए वीडियो देखो और आपको स्विमिंग नहीं आती, मैं तालाब में फेंकूंगा तो क्या होगा, ओके. अगर आप किसी को गाड़ी ठीक करते हुए देखो उसकी वीडियो और जब खुद करो, उसमें जमीन आसमान का फर्क होता है. That's true for any activity. You have to do it yourself. मैं जितनी मर्जी आपको कोशिश करूं आपको पढ़ाने की, unless you do it yourself, you won't be able to understand this material. You have to go home and practice and practice and practice. That's the only way to do well in this course. You literally have to get your hands dirty. Okay? बेहतर. I think अब ठीक है, ये दरमियान वाली. Okay. Okay, so calculus has 2 branches. And we'll be using both branches. Basically, you have to talk about derivatives, that falls under differential calculus, and you have to talk about integrals, that of course falls under integral calculus, okay. So first let's talk about why do we need these tools. So remember, our basic problem is how to describe motion. That's the very first problem that we deal with, okay. So whenever you're trying to answer some scientific question, look first at the simplest version of the scientific question. So how do objects fall down? Of course, if I throw something, that is quite complicated motion. But if I throw something straight up in the air, I observe that it actually just moves along one straight line. But that is still complicated motion, because first the object is going up, slower, stops, and then it reverses direction. Let's just look at an even simpler version of that. I just drop an object. Okay, like that. It just falls along one straight line. So that's the first problem I'm dealing with. Okay, I'm just going to describe how it falls down. Okay. What do I mean by that mathematically? So you have to learn how to translate these English statements into precise mathematical statements. That's what we mean when I said we construct a mathematical model. That's the first step towards that. Okay, so the object is falling down. You're basically going to measure, you drop it from here, you basically measure the position of the object as a function of time. So you write down x of t. X is the distance fallen by the object. Of course, sir, y इस्तेमाल करें, vertically move कर रहा है. Doesn't matter. Okay, I can use x for the distance that it falls down vertically. Okay, so this is a function. For those of you who have forgotten, आधी क्लास ये समझ के बैठी होते ये x multiplied by time हो रहा है. This is not position multiplied by time. This is that position depends on time. There's a relationship between the time and the position. It's some relationship which I have to figure out. Okay, and there may be some other quantities related to x, and there's a relationship between all these different quantities. Understanding this relationship between these different quantities is what is meant by understanding your model. Is what is meant by सर वो कॉन्सेप्ट समझ आ गए हैं जो मुझे आज तक फ्रेज की समझ नहीं आई कि सर वैसे सब कुछ आता है कॉन्सेप्ट नहीं समझ आए. अच्छा, anyway. Okay, so why do we need this? Because if I have this understanding of position as a function of time, I can then define, and we'll look at this in more detail, I can look at how fast the position is changing with respect to time, aka the speed or the velocity. And it turns out to get the speed and the velocity function, I have to take the derivative of the position function. So the language of calculus provides the natural language in which we talk about how fast an object is moving. If you're just restricted to this, you're just talking about where the object is at any particular time. But now calculus has provided you with the power to also answer the question how fast the object is moving. And then you can go one step further. You can talk about how fast the speed of the object or the velocity of the object is changing. That's another derivative. And I'll explain what this notation means. But for now, one important qualifier that you need to add is do not cancel these d's, okay? जिन आप जो सीनियर्स हैं आपके जिनकी आप बड़ी बात पे अमल कर रहे हो उनको गुरु बना के यूं करके बात सुन रहे हो उनमें से कई हैं जो ये करते नहीं हैं. So take their advice with a huge chunk of salt, okay? पूरे ट्रक लेकर, okay? Salt का जो है take their advice with that, not with a pinch of salt, okay? Don't do that, okay? Okay, so this differentiation tool, okay, this mathematics, remember in this course is a tool for you to answer different physical questions. Those tools should be secondary. Those tools are there to help you. Okay. ये मैं इसलिए बता रहा हूँ कि 4 हफ्ते बाद कई वो पूछ रहे थे सर वो जो FSC वाला तरीका था वो लगा लें, ये ज़रूर डिफरेंशिएशन करनी है हमने. I mean, you could do it, you could apply those ways in very simple problems, but in more complicated problems, you have to do it with the full arsenal of tools that you have. These tools are there to simplify your life, not to make your life more difficult. Okay? Right, and you should also be able to go the other way around. Why do we need to go the other way around? Because it turns out that experimentally, of course, it's simplest to measure this thing. Experimentally, ये चीज़ आप measure करते हो. You drop some object, you place a scale right next to it. You can, for example, shoot a movie of this, and then you pause the movie at different instants of time, and you note down the reading on the ruler, on the meter stick. So you get this function, approximately, okay. And then you can differentiate that function to get the speed. You can differentiate that to get the acceleration. But theoretically, if you want to make a model that allows you to predict the position of the object, it turns out that you have to go the other way around. You use essentially Newton's second law. You analyze the forces acting on the object to first figure out the acceleration, and then from that figure out the speed, and then from that figure out the position. So experimentally it goes this way. Theoretically it goes the other way around. Okay, so that's why you have to be able to go both ways. Okay, and it was of course the big achievement of Newton that he realized that in order to make predictions for the motion of objects beforehand, that's the way that you have to do it. And he gave essentially a recipe to deduce this. That recipe of course is Newton's second law. That in a nutshell is basically this whole course. ये आपने सिर्फ इस ब्लैकबोर्ड पे सारा कोर्स बने, ये I can supplement this with ये लो चलो, now you can all go home. Okay, that's literally your whole 4 credit hour. अगर अभी भी आर्ग्यू करो कि सर बहुत मुश्किल है, हमें नहीं आ रहा, मैं जान के मुश्किल का है, वो 5 साल के बच्चों को जबरदस्त झूले पे बिठाओ तो वो कहते हैं नहीं नहीं मुश्किल. Okay, so अगर अभी भी कहो तो ज्यादती है. Okay, or I always love to give you another example. Just put it into historical context. Newton wrote this in the 17th century. Not in exactly the same notation, but basically the same thing. Around in the 1660s, when the life expectancy in those days used to be half of what it is now. When there was no electricity, there was no Facebook, there was no internet, there were no washing machines, there was no electric lighting. Okay, most people didn't know where the next meal was going to come from. Disease was rampant. When Newton wrote it down, there was an outbreak of the plague in England. If those people can invent this, can discover this, surely आजकल के दौर में आप समझ तो सकते हो यार. इतनी तो बेइज्जती ना करो, अपनी बेइज्जती कर रहे हो करके ये बहुत मुश्किल है. ओके, ये समझ नहीं आ रही. Okay, what one fool can do, surely you can understand. And you're the biggest fool in front of you. Okay, so okay, anyway. Okay, so you need to be very, very familiar and very fluent in this language, because that's basically, look, I summarized the whole course in this mathematical language. Okay, right? If I wake you up at 3 a.m. in the morning by kicking you, you should immediately babble out, A is equal to dv by dt, v is equal to the integral of a, and so on and so forth. Okay. As in, these should be second nature to you. जब आप कोई problem solve कर रहे हो, you shouldn't be thinking too much about this. You shouldn't be thinking too much about the language. No, I mean, how do you become a good essay writer? Not by asking ChatGPT, of course, but if you want to do it yourself, you're stranded on an island. If you're good in English grammar, then you are much better essay writer, because you're actually thinking about higher level things. You're not thinking about the nuts and bolts of what you are writing. कि मेरी ग्रामर भी ठीक है, मेरी पंक्चुएशन ठीक है, कैपिटल लेटर मैंने सही डाला है, कोमा इधर इस्तेमाल करना है, ये इन चीज़ों में पड़े रहोगे, फिर ऐसे क्या लिखोगे? It's the same thing over here. अगर आप फंसे रहेगा कि डी कैंसिल होता है ऊपर नीचे क्या नहीं होता, लेट मी फिगर इट आउट हो गया, फिर आपने फिजिक्स क्या करनी हो गया. Okay? Okay, so the derivative. So let's talk about in general a function. Okay, I'll just do it very quickly. Okay, for those who are getting bored, इनकी जमाई बड़ी मुश्किल से रोकी हुई है. Okay, you have a general function. X could be any input to the function. For those of you who don't know, this is a function. A function is a rule, takes in an input, throws out an output. The output conventionally is given the symbol y, but again y could be anything. Okay, you could use your own name. So you can think, Aslam is equal to Tariq, and Tariq takes in, whatever. Okay, you can give it some other name. Okay, you don't need to give it short names. You can give it as long names. Okay, just like वो programming या variable names कुछ भी दे सकते. These are all just dummy labels. Okay, ठीक है. अच्छा, okay. So you have this function. The first thing that you have to do, and you'll see this in your recitation section as well, you should be able to visualize this function. You should be able to plot common functions. You already saw plenty of examples in your हाई स्कूल. क्वाड्रेटिक फंक्शन कैसे क्या प्लॉट की क्या शक्ल होती है, लीनियर फंक्शन, व्हाट डू यू मीन बाय लीनियर फंक्शन, व्हाट्स एन एक्सपोनेंशियल फंक्शन, एंड सो ऑन एंड सो फोर्थ. Okay, right. So then we talk about that given a function, the first tool that calculus provides you is you can talk about how fast a function is changing. That's basic derivative. So a derivative tells you three things. So it can answer it can give you three things. It gives you first of all the rate of change, and again I'll make this precise. अगर आप एक साइंटिस्ट हो, इतना वेग सी स्टेटमेंट से नहीं आपको सेटिस्फाई होना चाहिए. There's a very vague statement, rate of change. Well, how do I compute it? A very good practice to have as a scientist and engineer is कभी कोई चीज़ पर, well, how do I calculate this number? Just ask yourself that. Okay, if I'm given a set of quantities, I have some mathematical model. How do I compute this number that I want? At the end of the day, every scientific theory has to produce a number. Okay, so it gives you a rate of change. How exactly do we calculate that? Well, the derivative allows you to do that, and we look at it in more detail. That how does it allow us to do that? Okay. The second thing is it tells us is the change in the function. So if you know the derivative at a particular point, you can compute how much does the function change around that point. If the derivative is bigger, the function changes more. If the derivative is smaller, the function changes less. Of course, these are all related to each other. And it can also compute for you approximately the value of the function. What do I mean by that? If you know the derivative of the function at a point, if you know the value of the function at the same point, you can calculate the value of the function at neighboring points. Okay, so the derivative is an extremely powerful tool. The idea is that you slice essentially the function into small pieces, and if you know the derivative for each slice, you basically know what happens for the slice. Okay, so let's look at this in more precise details. So given a function, I just plot it. So you have some function. Let's plot the classic function. F of x is equal to x square. Okay, that's the classic non-trivial example, because the rate of change for a straight line is obvious. For example, if you have this, for a straight line, people essentially were able to solve this problem thousands of years ago. What do we mean by rate of change for a straight line? That problem is simple, because essentially for a straight line, the rate of change is constant. The power of calculus really comes in when things are changing. When things are constant, things are much simpler. Here the rate of change is constant. You can use any 2 points on the straight line to calculate the rate of change. You'll get the same value. Okay? But for this, the problem is much more complicated. It was a big mathematical mystery that how and whether can we even find out the rate of change at a given point. Because see, the problem is that to calculate the change, you need 2 points. Okay? So if I say that find the rate of change at this point, I say, okay, well, you need a second point. But where do I choose the second point to be? Do I choose it over here? But then you say, well, if you choose it over here, the function is continuously changing. That the rate at which the function is changing, that is continuously changing between the white point and the blue point. If I bring it closer, then it's changing in a different way. For that's a bigger change, then that's a smaller change. Okay, which second point do I choose? For a straight line, that question is moot because it doesn't matter. You can choose any point as your second point. But for this parabola, it matters which point you choose as your second point. You'll get different answers depending on where the blue point is. Okay? But I want the rate of change exactly at the white point. So the idea is that you make this blue point closer and closer to this white point, and then calculate the slope, calculate the rate of change. But you cannot make the blue point exactly on top of the white point. because then you get zero change. You need two distinct points to calculate the rate of change, but they cannot be, they should be very, very close to each other, but it cannot be exactly same. Okay? So you have this blue point and you have this white point. Let's calculate the rate of change. What do I mean by the rate of change? The rate of change is the change in the value of the function divided by the change in the value of x, as in the slope of the line joining this white point to the blue point. Okay? So if I calculate that, if I say that, okay, this difference in the x coordinate is delta x, this is x comma f of x, this blue point is then x plus delta x, f of x plus delta x. So the y coordinate of the blue point is f of x plus delta x. The x coordinate of the blue point is x plus delta x. The x coordinate of the y point is simply x. The y coordinate of the white point is f of x. Okay. This looks more complicated than what it actually is, but then the rate of change is simply the change in the value of the function, which is that, divided by the change in the value of x, which is x plus delta x minus x. And this, of course, is that. Okay? But like I said, okay, you get a different answer depending on where the blue point is. AKA, you get a different answer depending on what delta x is. But if you want the rate of change exactly at the white point, you should make this blue point closer and closer and closer to the white point. Okay? This business of this mathematical business of bringing the second point closer and closer to the white point, this thing is done by a so-called limit. Okay, so what we do is that we say that, okay, you take this ratio and you look at what happens to this ratio as delta x becomes smaller and smaller and smaller. What I'm doing, of course, over here is that I'm bringing the blue point closer and closer and closer to the white point, but not exactly on top of the white point. Okay, so you write that as limit LIM, and then in the subscript you write down that delta x goes to 0. This is defined as df by dx. That's your derivative. Okay, this thing in general, so I first of all need to tell you that this thing in general will be a function. The derivative of a function is another function. You can calculate the value of that function at different points. The value of that function at different points tells you the rate at which the original function is changing at different points. Okay, so the output of this thing is not a number, it's another function. Okay? Okay. Great. Let's apply this in practice, okay? But before applying this, let me just make sure you at least get the idea of this limit down. So for example, you have a function sine of x over x. And I say this is f of x. Very simple. I say what is f of 0? And divide, because you get sine of 0 is 0 and x being 0 just gives you 0 divided by 0. That's something undefined. But what is f of 0.001? This is in radians, of course. Okay, so throughout when we talk about sines and cosines, we use radians as your measure of angles. What do you get? किसी के पास calculator है तो करके करो जरा. If you have a calculator. Yeah. So this will be close to 1, 0.99 कुछ आएगा या 1.00 something आएगा. I've forgotten which one do you get. Okay, so and if you use an even smaller value, you get an answer even closer to 1. Even smaller value. You get an answer even closer to 1. Okay. So notice that at exactly 0 this thing is undefined, but that doesn't mean that we cannot talk about the limiting behavior of this thing. The idea is essentially that as x becomes smaller and smaller, if you just look at the denominator, of course you will say that this thing blows up. But hang on, look at the numerator as well. As x becomes smaller and smaller, the numerator also becomes smaller and smaller. That's the key point. So if both numerator and denominator become smaller and smaller, maybe the ratio does not blow up. And that's exactly what is happening in this case. And that's exactly what happens for the derivative as well. For the derivative, as delta x becomes smaller and smaller, the denominator sure becomes smaller and smaller, but then so does the numerator. Okay, so don't think of that, okay, this is undefined, this blows up. Well, you're making the mistake that you're setting delta x exactly equal to 0. But the limit does not allow you to set it exactly equal to 0. It allows you to set it closer and closer to 0, but not exactly equal to 0. Okay? Right? Okay, so with that done, let me just give you another example just to convince you. F of x is equal to a raised to power x minus 1 over x for some value of a. Say a is equal to 2 or a is equal to 3. Okay. What is f of 0? Undefined. If you put in exactly x is equal to 0, you put that in exactly, you get 1 minus 1, which is 0 divided by 0, it's undefined. Okay? So this is, but if you say that a is equal to 2, for example, you put in f is equal to 0. F of 0 and you do the same exercise. Consider values of x closer and closer to 0, but not exactly equal to 0. And you note down these values, you will find, do this, okay, just to convince yourself. जब तक आप ये खुद नहीं करोगे, आपको नहीं convince होना. You will find that essentially these values are approaching the value of roughly 0.693, I think. If you put a is equal to 3, you will find that these values approach roughly 1.1. Okay, so even though this function is not defined at x is equal to 0, the limit is. And the value of the limit depends on what a is. So for a is equal to 2, you get that the limit is 0.693. For a is equal to 3, the limit you get is 1.1. Maybe in between there's a special value of a such that this limit is 1. And you can use that to define this special value of a. And you say that that value of a is given a special symbol called e. And the value of that is approximately 2.71. You can use that to define e. That e is the number such that limit x approaches 0 of e raised to power x minus 1 over x is equal to 1. That's how you can define e. Okay? Right. So with that out of the way, let's just calculate this derivative for different cases. Okay? So for example, let's take a classic example. F of x is equal to x square. How do I find out the derivative of this thing? You should be, सर ये तो हम कैलकुलस में करेंगे, ये इधर क्या कर रहे हैं, ये तो सारी मैथ्स है. Hang on, okay. Again, this is the whole objective of this thing is to get you fluent in this language. थोड़ा बहुत ये बोलोगे language तभी fluent बोलोगे ना. Okay. Otherwise you are like, you know, okay, English की किताब में नहीं खोलनी beyond class 3, लेकिन मैंने आगे वो novel लिखने चलना है मैंने. Okay. Okay, so the derivative of this function is given by definition. So this is how you define the derivative. That's why I put in 3 lines. That's a definition. Okay. So you have f of x plus delta x, which in this case will simply be x plus delta x whole square minus x square divided by delta x. Okay. and then I can simplify both the denominator and the numerator. So I have x square plus delta x square plus 2x delta x. I applied one of the formulas that you still remember probably, a plus b whole square is equal to a square plus b square plus 2ab. अगर मैं आपसे कहूँ कि ये डिराइव करके दिखाओ, probably आपने उधर ही कहना ये तो नहीं मुझे आता, but never mind, okay. And you have minus x square, okay, divided by delta x, right? This x square, this minus x square of course cancels this x square. Of course, the numerator should be a very small number, because you are subtracting the value of the function at two very close nearby points. Okay, ये आधी क्लास ये करना भूल जाती है, मुझे पता है, माइनस एक्स स्क्वायर करना भूल जाती है फॉर एग्जांपल. That should immediately give you a sign that something is very wrong. The numerator should be a very small number. Okay, and then you can write this thing as 2 plus 1 over 5, remember, is 2 by 5 plus 1 by 5. आपके छोटे भाई होमवर्क जो है वो करता है, वो ऑफ कोर्स ऑपोजिट करता है. 2 by 5 plus 1 by 5, that's what is given in his homework, and he has to find out the 2 by 5 plus 1 by 5 is equal to 3 by 5. You know, आप जो है your father and mother से बच्चा जीनियस है मैथमेटिकल और आपको गुस्सा जा रहा होता है, but anyway, I'll be using this now. This is, you split this fraction up. Delta x square divided by delta x is what? Delta x, and 2x delta x divided by delta x is what? 2x. So you essentially write this as, this whole thing becomes so this becomes limit delta x approaches 0 of 2x plus delta x. And now you say, okay, delta x is much smaller than this thing. So in the limit that delta x approaches 0, this thing is just 2x. So the derivative of x square, the derivative function. So when we say derivative, normally that's a shorthand for the derivative function, because this process of taking a derivative produces another function. So be very careful. जब हम कहते हैं the derivative, do we mean the whole function or do we mean the value of that function at a particular point? The context makes it clear. शुरू में I'll be very careful in stating what exactly do I mean. But later on, of course, you have to deduce it yourself. कि मैं क्या मतलब है मेरा? Do I mean the whole derivative function or do you mean just the value of that function at a particular point? Okay, they're not the same thing, of course. One is a number, the other is a whole function. Okay, so this is the derivative. Of course, आपको सर आपने क्या टाइम ज़ाया किया है? मैंने अच्छे खासे पैसे दे के अकेडमी में याद किया था कि ये पावर नीचे खींचते और 2 में से 1 माइनस कर देते हैं. Okay, besides the point. Okay, you can do that, sure, but so can a trained monkey. Okay, maybe after some training. Okay, but the trained monkey cannot do is to actually understand what he or she is trying to do. इसका मतलब क्या करने का? Only when you understand the meaning of what you are doing can you then possibly apply this tool to new situations. Okay, some tool that you are not comfortable with, वो आप उठाओगे नहीं कभी भी. हाँ. Because delta x, you are taking the limit that delta x approaches 0, right? In the limit, it gets removed. Okay. Again, this is not the rigorous definition. In your calculus course, you do it much more carefully. But this is not a calculus course, so I can get by with this much. Okay. Okay. Let's do it for another example. Let's do it for something that we just did, a raised to power x. इसका डेरिवेटिव निकालते हैं. Okay. Okay. df by dx now is equal to limit delta x approaches 0 of a x plus delta x minus a to the power x divided by delta x. This is just by definition. Okay. ये आपको पूरे कोर्स में बेयरली कभी इस्तेमाल करना होगा, but the important point again is to थोड़ा सा आपका हाथ चलाने की बात है कि थोड़ा सा मैथमेटिक्स से दोस्ती करने की बात है. ओके, this is equal to limit delta x approaches 0 of, you can factor out a raised to power x from here. So this is a raised to power x times a raised to power delta x minus 1 divided by delta x. Because this thing is a raised to power x plus delta x minus a raised to power x. All I have done is to peel off this factor of a raised to power x in the numerator. And then you find out that, oh, you look at this closely. So one very important step in any mathematical proof is to stare at the thing very closely. Okay, so if you stare at it closely, you realize that this a raised to power x does not even contain delta x. So it doesn't see this limit. You can pull this a raised to power x outside the limit. अब delta x को जो मर्जी करो ये तो उसको देखेगा ही नहीं. So you can write it outside the limit, and you get that. And if you look at this thing now in the blue box, ये क्या चीज है? ये मेमोरी का आपका इम्तिहान है. अभी आपने देखी है यार, 2 मिनट पहले देखी है. The only difference is that over there I was writing instead of delta x, I was writing x. That's the whole reason why I did that weird, seemingly weird example. Okay. So you already know that limit of x approaches 0 of a raised to power x minus 1 divided by x is a number that depends on a. If you choose the value of a to be e, this number is 1. And so if you choose the value of a to be e, what do you get as a derivative? You simply get e raised to power x then. ये सिर्फ बच जाएगा, ये सारा blue box 1 हो जाएगा. That's why you talk about e when it comes to calculus. A being e is the only choice such that when you differentiate an exponential function, you get exactly the exponential function back. For any other value of a, you'll get the exponential function back sure, but you'll get some other number as well. और मैथमेटिशियन फिजिक्स मेरे ऑफिस में आगे आपको लगेगा कि बहुत गंद शंद फैला होता है हर वक्त. ओके, रैंडम प्रोसेस चल रहे होते हैं. But trust me, when it comes to mathematics, we are all very clean. Okay, we like things to be very neat and tidy. Okay, we don't like any extra stupid constants. Okay, यही है, a e है ना, उसी को लिखा है. ये सारा blue box has become equal to 1. So it's basically for a being equal to e, this thing is e raised to power x times 1, which is just e raised to power x. Now, having done that, अब आप ये बताओ कि ये नंबर जो हमने निकाला था, once again, when I deduced I claimed that this is 0.693. How can I deduce this? Well, okay, let's try it. Okay, and this is the value of playing around. Define this function. Take the derivative of this function. Okay, and if you take the derivative of this function, let me just write down this function. If I take the logarithm on both sides, again I'm assuming कि आपको logarithm का पता है. Okay, this thing is x ln 2. If I take the logarithm on both sides, you get ln f is equal to x ln 2. And therefore, I can write f of x in another way. E raised to power x ln 2. So instead of writing down that f of x is equal to 2 raised to power x, I can write down the same function in terms of e. I'm sorry for the PTSD. जिनके पेपर 3 या 4 के अंदर बुरे नंबर आए थे, वो जो है वो कह रहे हैं कि सर ये आप क्या कर रही हैं, बड़ी मुश्किल से हमने अपनी यादें जो हैं, तो आप मुझे बताओ आप इधर क्या कर रहे हो. ओके, अच्छा, so next you know what I'll do. Okay, so this thing, so I have to prove this. The point being कि जब भी आप कोई प्रॉब्लम करो मैथमेटिकल का, साइंस का, at university level, it's not obvious how you'll show it. You have to try different things. You have to be brave. Okay, You have to be intellectually brave. Actually try out different things and see what happens. Bari freedom hai, as long as you're doing something mathematically valid, you can do it. So I don't know where I'm going with this. I've just defined, I've looked at, okay, 2 raised to power x hai. Iska agar derivative leta hu, so I get something that looks like this. Maybe by looking at the derivative of this thing in 2 different ways, maybe I can then show this. That's my basic strategy. Okay, so one way to take a derivative is that, okay, I know how to differentiate e raised to power x. So I write down this function in terms of e and then I differentiate it. Okay, so I do that. This is something that you'll see in your physical problems over and over again. बार बार मसला ये होता है, स्टूडेंट्स कह रहे होते हैं कि भाई सर आपको कैसे पता चला इस तरह करना है? Well, practice. You practice enough problems, you build a nose for it essentially. Okay, वो instinct आपने develop करना होता है. It's not something that I can teach you in 2 lines. Okay, so anyway, so you have f of x is equal to e raised to power x ln 2. इसका derivative क्या होगा? So you have e raised to power x ln 2. ये वैसे का वैसे फंक्शन रहेगा और साथ क्या आएगा? ln 2 by the chain rule. You get ln 2. And this thing, of course, I can rewrite as 2 raised to power x. So I can write this as 2 raised to power x ln 2. Because e raised to power x ln 2, of course, is 2 raised to power. ये सारा काम मैंने सिर्फ इसलिए किया था ताकि उसको differentiate कर सकूं. I can also differentiate the same function in another way. F of x is equal to 2 raised to power x. I can go back to the definition. So df by dx, the same derivative, is limit delta x approaches 0 of 2x plus delta x minus 2 raised to power x divided by delta x. And this you have already seen is 2 raised to power x limit delta x approaches 0 of 2 raised to power delta x minus 1 divided by delta x. हाँ कौन सा e को 2? ये कर सकता हूँ because this is a simpler way of writing this down. The only reason I was writing it like this was to differentiate it. एक दफा मैंने, once I have differentiated it, it has essentially served this purpose. Okay. Okay, now if you look at this and this is exactly the same thing. Both are derivatives calculated in different ways. It's the derivative of the same function. One I've calculated using this number e, one I have used the basic definition. Since this is the same and 2 raised to power x is the same in both, this thing is exactly the same as that thing. And so this limit is nothing but ln 2. ln 2, if you punch it in your calculator, that's 0.693. Okay. Right. अभी मेरे पास 5 मिनट हैं. Relax करो. Okay. Now once you have done that, let's look at the बाकी चीजें बताइए. Okay, so the derivative I can also write this down in shorthand as this delta f divided by delta x, the change in the value of the function divided by the change in x. If I'm talking about small values of delta x, which is of course exactly what I'm doing, I can compute the value of this derivative at a particular point. I can then find out the value or the change in the value of the function that occurs over a small interval. Let me explain that, okay? What do I mean precisely by that? So if you have some function, again, if you know the value of the derivative at this point, so then that means that you know the slope of the tangent line essentially, okay? You essentially know roughly the slope of the line that joins this point and a very close nearby point. The value of the derivative at this point, let's call this point has coordinates x naught, y naught. If you know the value of the derivative at this point, this white point with coordinates x naught, y naught, you then know the change in the value of the function that occurs in going from the white point to the blue point. Okay, because you know the slope of the line that joins the white point to the blue point. Okay. So in other words, you are essentially saying you could write down df by dx at x naught. What does this notation means is that you have the derivative function. This vertical line says calculate this derivative function at x is equal to x naught. So this is a number. This is now not a function. Okay? If you multiply this number by delta x, you essentially get delta f, the change in the value of the function. Okay? Let's try this out. So for example, let's take the exponential function. Exponential function, of course, looks like this. This is 1, this is origin, then it blows up. If I say that I give you the value of the function for the exponential function is 1 at x is equal to 0, what's approximately the value of the function over here? Okay, so this original point is 0, 1. Okay, what's approximately the value of the function at this white point? You use this. You can calculate the value of the derivative function at this point, that's this thing, multiplied by the change in the value of x in going from this point to that point. So if this point has coordinates x, y, then you can use this to calculate the change in the value of the function and thereby the value of the function at this point. Okay. Let's just do that very quickly, okay? This is straightforward enough. What's the derivative of the exponential function? Okay. What's the value of the derivative function? So f of x is equal to e raised to power x. The derivative is, what's the derivative? ये मैंने नहीं आपको रिवाइज करवाने. You are supposed to sine of x derivative, cosine of x derivative minus sine of x and so on and so forth. These are all there in the formula sheet, by the way. Okay, but if you are, trust me, if you are looking in the formula sheet, okay, what is the derivative of x cubed, you have much bigger troubles ahead of you. Okay. Okay. So you have this thing is df by dx is of course also exponential function. That's the special thing about the exponential function. कोई भी polynomial function, if you differentiate it, you don't get back the same thing. You always get a polynomial of 1 degree less, 1 degree smaller. But for the exponential function, you get back exactly the same exponential function. The rate of change of the exponential function is the function itself. And this thing at x is equal to 0, ये जो मैं ये कह रहा था, x naught मेरा अब 0 है. What is this thing? This is 1. So then I can say the change in the value of the function f of x minus f of 0. Change क्या होगा? इधर f of x की value होगी function की, इधर f of 0 होगी. So the change in the value of the function is f of x minus f of 0 is equal to 1, this thing, multiplied by delta x. What's delta x in this case? X minus 0, which is x. Okay, and f of 0 for this function, of course, is 1. So the exponential function for small values of x is simply 1 plus x. Near x is equal to 0, the exponential function looks like a straight line, but very near it. Far away, of course, it blows up. Okay, sir, why is this important? Well, in many cases, you will have, for example, some exponential function appearing. But the parameter that goes into your exponential function, suppose करो e raised to power x है आपके formula में कहीं. but you know that the physical parameters that are going into this formula are such that x is small, then you don't need to deal with this complicated monster. You can replace this e raised to power x simply by 1 plus x. That gives you a much better understanding of what is going on. That gives you a much simpler understanding of what is going on compared to just the original e raised to power x.
Sir, is आपकी step में आपने f of x minus f of 0?
That's delta f.
Yes, sir, वही मैं पूछना था
Delta f is the value of the function, difference in the value of the function between the white point and this point.
Yes, sir.
Okay? ये blue point है एक और एक white point. Given the value of the function at the blue point and the derivative at the blue point, I can use the value of the function at the white point.
Yes, sir. I am asking why did you multiply 1 with x instead of e of x?
Right. You have to look at the value of the derivative. इसकी value निकालनी है. So you first find out the value of the derivative at x is equal to 0. The derivative function is e raised to power x. The value of the derivative function at x is equal to 0 is 1. You need the value over here, not the function.
And the value of delta x is
X minus 0. Because for the blue point, the x coordinate is 0. For the white point, the x coordinate is simply x. Okay? So again, ये आपको इसलिए confusion हो रही थी because मुझे पता है स्कूल में you don't pay enough attention to the distinction between these two things, the derivative function and the value of the derivative function at a particular point. One is a number, the other is a function. It's not the same thing, okay? Of course, knowing one, if you know the derivative function, you can of course calculate the number. Okay. Delta x क्या? Delta x is the, remember, delta x is the difference in the x coordinate between the 2 points that I'm considering. You have the blue point with x coordinate 0. You have the white point with x coordinate x. So what's delta x? Okay. Again, जो भी symbol लिखूं, whatever symbol you write down, always be clear कि उसका मतलब क्या है. If you're not clear what it means, then you might as well be writing gibberish हो गया. ठीक है? Because there's a change in the function. ये delta f है. कौन सा? f of 0 क्या होगा? f of x जो है आपका e raised to power x है. f of 0 is 1. This is minus 1. Take it to the other side, it becomes plus 1.
So could you please explain what df over dx at x or
df by dx is the derivative function. This thing is the value of the derivative function at x is equal to x naught. X naught is the point that I am considering is 0. So I'm saying that if I give you the value of the exponential function at x is equal to 0, tell me the value of the function at a slightly later point with x coordinate x.
and we're saying that df of dx at x naught multiplied by delta
Yes. Okay. आज के लिए इतना ही है.